All right, so we're going to continue with day 4 today in our Unit 1A lesson. So if we go to day 4, we're going to look at more geometric terms to know. So a geometric term that we're going to first talk about is called an undefined term. It's any abstract term used to describe geometric figures. So when we say abstract, that means it's those things that we talked about yesterday that can be invisible, like lines, planes, points, right? The point is just a location. And invisible, a line, you can't really have an actual line because they go on forever and ever and ever. So there's no physical line in existence. There's only, like if I look at this pencil, there's only representations, right? But this has 2 endpoints, so it's more like a segment. Right? So our undefined terms are just abstract notions that we just use to describe what's happening in figures. Okay? The first thing I want to talk about when we talk about undefined terms, there's a couple things that are going to come up often, and we need to know that they happen because, as I told you yesterday, our undefined terms can be invisible. So super important to remember that our undefined terms can be invisible. So for example, anytime I see 2 points just out in the world anywhere, I know that there's only one, that there is a line that will connect the 2 points. Okay? So the first thing I'm going to write down here, I'm going to write down 2 things, one on the left, one on the right, is 2 points will always make a line. 2 points will always make a line. Okay, so if I ever give you a problem on an assignment where I've got point A and I've got point B, and I ask, is there a line that connects point A to point B? What's my answer? Yes. Yes. Even though I can't see it in the picture, I know it exists and I know it's there. So even if I don't have a picture, if I say, is there a line that connects points X and W? What's your answer? Yes. Yes. I don't even need to know where they are. I know that there is a line that will connect them. Okay? The next thing that we need to know is that if we have 3 points, 3 points will always make a plane. 3 points will always make a plane. Okay? So, for example, if I have C, D, and E, those 3 points will make a plane even if I don't have that little parallelogram drawn around them. You could think of your paper, right, as that plane. It's that flat surface those 3 things are on. Okay? If I have 1 point that I draw on my ceiling here and I call it X, and then I draw another point on the floor in Miss Poston's room, Y, and then I draw a point on Mr. Moore's wall, could I make a flat surface between those 3 points? Like right here? Yes. Okay, so no matter where the 3 points are. What if I don't tell you where the points are? What if I just say, is there a plane that connects points E, F, and G? Yes. Yes. It doesn't matter where they are, there is a plane that will connect them. Okay, so if I give you 3 points, your answer is always yes. If I give you 4, then you need to know more information, right? Okay, now let's talk about what it means to be an intersection. An intersection is the set of points that 2 figures have in common. Okay? So 2 lines, if they cross each other, they're going to intersect in only 1 point. Okay? So if I see these 2 lines here, I can see if I just asked you to describe this picture, I would say it's 2 lines intersecting. Right? And I know they're intersecting in 1 point. Now, if I have labels on my lines and my points, then I can describe it better, right? If I have this right here and it maybe has a little lowercase a next to it, and this one here if it has a lowercase b next to it, I know, even though we represent it as a line, it's a set of points, so there's a million infinite little points that make up these two lines. Well, there is a point, even though it's not drawn, there is a point that is where they cross. We'll say point F. Okay? So if I gave you this picture and I wanted you to describe it, I could say line A and line B intersect at point F. Or point F is the intersection of line A and line B. You could say it either one of those two ways. So however I write it might be different from how you write it. I'm going to say point F is the intersection of lines A and B. Or you could say of line A and line B. Notice F is capitalized because it's a point. The A and the B are lowercase because they're the names of the lines. Okay, again, super important with your notation. Okay? All right, sometimes a line and a plane intersect each other. One of two things will happen. Either when they intersect, they'll intersect at one point, or they'll intersect at every point, an infinite number of points. Okay? Who can tell me what this means right here when I see these little dotted lines?
It's behind the object.
Yes, it's behind the object. Okay? So what is happening there? I have this orange sheet of paper that I used in first period. What's happening there is if I have this sheet of paper and it's representing a plane for me, and if I have this pencil and I say it's representing a line for me, what's happening in that picture is the pencil is going through the line, right? And so I can see the pencil on both sides if I move it around, right? But if I'm looking at the plane flat, I wouldn't see part of the pencil here where it goes back behind that plane, right? I can see it in front of the plane, and I can see it when it goes past my representation of the plane, but in here, I can't see it. I know it's there. So what we do when we draw that is we make a little dotted line, so that tells whoever's looking at the picture that really it's continuing that line. It's just we know that means it goes behind that part of the picture. Okay? So if I look back at that again, I probably shouldn't have zoomed in yet. If I look back at this again, I can see that my pencil only touches that paper in just this one little point, right? So just that one little point. So this line intersects this plane at that point, or that point is the intersection of the line and the plane. So I need names for my line and my plane, so that way I can actually write that out, okay? So let's say this is line, I've used A, B, we'll do line C. And then points, my next point would be, we'll say G. Okay? And then if I want to name my plane, we'll call it plane, I'm going to go with M, just because I don't know why. Remember, to name a plane, you can either use the 3 points, because 3 points always make a plane, but the point should not be in a line. Or find a letter in the corner that's not associated with a point. Okay? So if I wanted to describe that part of the picture, I covered up the little line on the bottom. If I wanted to describe just that, I could say line C intersects plane M at point G. Or I could say point G is the intersection of line C and plane M. Or plane M and line C. Okay, so again, multiple different ways to write this. I'm going to say line C, lowercase c, intersects plane M at point G. Okay, that line's only touching that plane in just that one spot. There's also a case where you could have infinite points. Okay, a place where you could have infinite points, if I look at that same plane I was looking at, If I take a marker and I actually just draw a line on that sheet of paper, because the paper keeps going forever and ever and ever, the fact that this line keeps going forever and ever and ever doesn't mean it's going to come off the plane when I go over here, because the plane keeps going forever and ever and ever. Okay? So every point in this line is also in this plane. Every point in this line is also in this plane. Okay? Okay? So just to kind of review, okay, I know I've been using the little letters on the end, but remember sometimes when the line gets up in the morning it forgets to put its name tag on, but some of its points are labeled. Let's say I have an H here and a J here. If I want to say, and you'll have this on your assignment today, it'll say, name this picture. Okay? To name that picture, it's the line that goes through points H and J. I don't want to write out the line that goes through points H and J. So remember we talked about yesterday, we can take that H and J and put a little line above it, and that means the line that goes through points H and J. And we can say is on, or we can say is contained in, you'll hear it sometimes like that also, is on plane M, or is in plane M, or is contained in plane M. So different ways you'll hear it. Or plane M contains line HJ. Okay? So make sure you're using your notation so you don't have to write it all out, because otherwise it takes like a huge sentence to do. Okay? All right, so we talked about what happens when two lines intersect. We talked about what happens when one line intersects a plane. Now we're going to talk about what happens when two planes intersect. And it tells us two planes intersect in a line. Okay? So if I think about the floor as a plane, and I think about the wall as a plane, okay, which means they don't just stop at this room, right? This floor keeps going to the next room, right? It keeps going to the next room, and as a plane, it even extends past the F building, right? Same thing with that wall that we're displaying the notes on. It doesn't just stop in this room, it goes down to the classroom underneath us, okay? So it extends down, and the actual plane itself, the invisible part, would extend up to the sky and down through the earth, right? So the plane keeps going on forever and ever and ever. So if we think about where that wall, that's a plane, and where the floor, that's a plane, where they intersect is going to be along the baseboard, right? The line along where the bottom of the wall and the edge of the room meet, okay? So that's kind of what this is representing. If this is like our classroom over here, okay, this would be the room next to it. This would be the room underneath us. And this would be the room like diagonal down below us. Does that make sense? Okay? And so where these are going to intersect is going to be all along this line. This is like the baseboard along the bottom of the floor there. Okay? It's going to be all along here. Okay? So I can see that I have, what's the name of this plane that's standing up? Plane Q, and this one is plane P, and they intersect at line AB. Can I call it line BA? Yes. I sure can. Order is not important when it comes to naming a line. Okay? If there was a third letter C, could I call it AC? Yes. Could I call it BC? Yes. Could I call it CB? Yes. CA? Yes. Yeah, as long as you put that line symbol above it, you're good. All right, so I am going to say, there's a couple ways I can say line, or plane Q and plane P intersect at line AB, or line AB is the intersection of plane Q and plane P, or line AB is contained in both plane Q and plane P. That means it has to be the intersection because it's in both. I'm just going to see what's the quickest way to probably say it. Plane Q and plane P intersect at that line? Yeah. Plane Q, capital Q, and plane P intersect at point, nope, not at point, at line A, B. If I just put AB, it's not correct because I need to make sure that I say it is the line AB or line BA, but I need that line symbol. And I have to use capital letters, all capitals there. Okay? Sometimes you'll be given a picture that's a box, and when you're given a picture that's a box, a lot of times you'll see letters on all the corners, so A, B, C, D, E, F, G, H, okay? And so to name a plane, let's say I wanted to name, that's a D, it kind of looks like an O. Let's say I wanted to name the top plane. If I want to name the top plane, all I have to do is pick 3 letters from the top. So I could go A, B, C. Or if I wanted to spell something, I could say D-A-B, plain dab, right? I'm going to go with that. Plain dab, capital letters, plain dab, intersects, plane. Let's intersect, I guess this side right here, the kind of right-hand side-ish. So I'm going to pick 3 points from the right-hand side. There's no vowel there, so I can't really spell anything. So just D-H-G, I guess. Now, since it's 2 planes, I know it's going to intersect at a line. What 2 letters are in both the top plane and the side plane? Did you say G as in?
No, I said D.
Oh, D as in dog. That's in both planes, but we need 2. What else is in both planes? C, right? Even though we didn't name it here, it's part of that plane. Even though we didn't name it here, it's part of that plane, right? So D and C. Now, in my picture, it's only a segment. Does that mean I name it a segment? No, because I'm talking about plane DAB and plane, the planes go on forever, which means the intersection also goes on forever. So it intersects in line DC. Does that make sense? Hopefully.
Yeah.
Awesome. Okay, let's look at the back. We're getting there. Another common term you're going to hear a lot this year is the word congruent. And its symbol, it looks just like the equals, but it has a little squiggle on top. And it kind of means equals. It means you have equal measures. Okay, so when I look at a segment, let's say this is A, and this is B, and this is C, and this is D. If I were to get out a ruler, and I was to measure AB, and I said the distance from A to B, that's how we write that, just without any symbols above it. If you don't have any symbols above it, that means you're talking about how far physically is it from A to B. And if I measured it and I said, oh, it's 5 units, whatever my units are. Okay? And then if I did this, I used the same ruler, and I measured CD, and I said, okay, well, CD is also 5 units. So therefore, that tells me that AB equals CD. So the measurement of AB is equal to the measurement of CD. That's what this is saying without the bars. Okay? Congruent is when you're naming the segments if the 2 distances are equal. Then we can say the segment with endpoints A and B is congruent to the segment that has endpoints C and D. Could I call this segment BA?
No.
Yes. Could I call this one DC?
Yes.
Yes. Okay. Then it also talks about something called tick marks. Tick marks show congruence on segments. So if I measure them and I see that they're both 5 units, I can add these little like hash mark, tick mark things. If I measure them and I show they both have the same measures, then I can add tick marks. Or if I do some sort of algebra, right? If I say this equals 2x and this equals 10, and I'm also given that x equals 5. Well, 2 times 5 is 10, so that means I can prove they're both 10. I can add tick marks. Does that make sense? So either you measure them and see they're both 5, if you know your segments are to scale, or you do some sort of math that you can prove they're the same measurement, then you can add the tick marks. Sometimes in diagrams, the tick marks will already be there for you. That just means you don't have to do the proving that they really are equal. You just know they are. Okay? So important about congruence. Okay? And tick marks mean they're the same. It is important to make sure that you don't just add tick marks because something looks like it's equal, because oftentimes you will see this sort of situation going on. If I just look at where that dot is, I might go, oh, that's right in the middle. Those two sides are equal. But then I might do some algebra and find that that's actually the case. And it's not, they're not equal on either side. I can't add tick marks. Okay? Sometimes I might do math and find that it is in the middle even though it doesn't look like it's in the middle. That happens a lot in this class, and unfortunately that's just the nature of geometry. You can't trust the pictures. Geometry is real sketch like that. Just can't trust it. Geometry can't be trusted. Okay? Speaking of that, a midpoint is a point that divides a segment into 2 equal lengths. Okay? So if I have point E and point F, if I have a midpoint, then it's going to be right in the middle. And that's only if it's to scale, it's going to look like it's in the middle. If I ever say, why is that the case? And you start answering with me with, well, it looked like it was there. I'm going to say, you can't say look like. That's not a proof step. Okay? So you either have to be able to mathematically prove that the tick marks belong there, or they have to have already been given to you. Okay? So you either have proven mathematically that there's tick marks, or there are already tick marks that came with the picture. Okay? So if you have the tick marks already on the picture, or if you mathematically proved it's in the middle, then we can say G is a midpoint of, how do I name the whole segment?
F, E, F.
Could I call it FE?
Yes.
Or EF?
Yes.
What kind of letters do I have to use? Capitals. I'm going to go FE. What is that, iron?
Yes.
Look at me integrating science into my geometry lesson. I only know a couple of them, like Fe is iron, Na is salt, and G. AU is gold, because if somebody steals your gold watch, you're going to say, AU, give me back my gold watch.
That's good.
That's how I learned it. Okay, sorry, I'm off topic. Collinear points. Co means together, right? Like I work with my co-workers. We work together. Co means together. Line means line. So together on a line, collinear points are points that lie on the same line. Collinear points are points that lie on the same line. Because co means together. Okay? So if I have this line here, and I have, it's made up of an infinite number of points. But let's just go with M, H, and S. Go, Marshall. I can say that points M, H, and S are collinear. Comma, comma, and S are collinear. Okay? What if I add another point here and call it J? What about J, M, H, and S? Are they collinear? No. Points M, H, I should have put the J first. J and S are, you can say not collinear, Or you'll see it a lot written as non, with a hyphen, collinear. Non-collinear. What about points J and M? Are collinear or non-collinear?
Collinear.
Why are they collinear? Because you can make a, well, there's an invisible line there. There sure is. Remember I told you, it doesn't matter where the 2 points in the whole wide world are. They're collinear, right? I could have a point here and a point in Australia. I was going to say Zimbabwe. In Australia, that sounds more fun. In Australia, and I could draw an invisible line. It might have to go through the earth, but I could draw it. Okay? So they are collinear. What about points R, A, and M? R, A, and M. Here, here, and here. So I heard we can make a line. I heard they're non-collinear. If you have more than 2 points and they look like they're in a line, can we say it's true if we're saying look like?
No.
No, because our eyeballs are not microscopes. One of those points, even if they really do look like they're in a line, mine look like it could be a little curved, but even if they look like they're exactly in a line, one of these 3 points could be just a fraction of a fraction of a fraction off the line, and our eyeballs wouldn't be able to see it. So if you have 2 points and you don't see a line, it can be invisible. But if you have 3 points, we can't for sure say they're collinear. However, we also don't know for sure that they're not collinear. They could be. So for points R, A, and M, we don't know. We need more info. We can't say they're collinear. We also can't say they're not collinear, right? All right. If collinear points are points on a line, then coplanar points are points on a plane. Okay? So let's say I put 3 points on this plane. R, A, and M. We can say that points R, A, and M are coplanar. Oops, AR. I know it looks like coplanar, but it's planar. Okay? What happens if I draw this point over here, S, and I say points R, A, M, and S? Those are non-coplanar. I will get to you if I can, but I have a lot of notes to do. I'm going to have to send an office aide. Huh? Okay, they'll probably send an office aide to get you. All right, so the next one I'm going to ask you is points R, A, and S. R, A, and S. So that would be like, so R maybe is there, right? On the ceiling where the intersect maybe. And A is over there. M is over there, right? So R, A, M. And then S is off the plane, so maybe S is in the floor. So R, A, and S. Is there a plane between R, A, and S?
Yes.
Yes, because remember we said 3 points will always make a plane. So even though we don't see it there, I could, if I was a really good artist, which I'm not, I could potentially draw that. Okay? I'm not a good enough artist to draw that. I can draw 2 planes intersecting, and hopefully by the end of the lesson you can too. But I don't know that I could draw that one. But we say are coplanar. Okay? All right, look at number 1. Does anybody want to tell me, raise your hand if you want to tell me how you would describe that picture? Yes.
Line L passing through point Q.
Line L passing through point Q. I like that. Line. Notice they did a little cursive lowercase l because of the little printed lowercase l looks like a 1 or a lower, so like that could be a 1 instead of an L. Line L passes through point Q. Is that the only way we could have said it?
No.
No. How else could we have said it? Yes.
Point Q intersects with line 1.
Point Q intersects line L.
I mean line L.
Line L intersects point Q, right? What about point Q is on line L? Would that work? Yeah, so again, more than one way to say it. All right, what about number 2? How could we say number 2? Yes. Line AB intersects. What did you call S and T?
Plane.
Is that for me?
Yes, it is.
Oh, I love you. I promise I'm going to come visit you.
Okay.
I might come do it today during 8th period. What do you have 8th period?
Coffee.
I'm going to come today during 8th period.
Okay.
I love her. Okay, sorry, I'm recording this lesson. Okay, so line AB is the intersection of, what do we call those?
Plane.
Planes S and plane T. So line AB, but I don't want to write out the word line. I'm going to say line AB. Could I have said line BA?
Yes.
Yes. Is the intersection I can reach it. Okay. Of plane, capital S, and plane, capital T. Or plane S and plane T intersect at line AB, right? Different ways you could say it, and it's still the same thing. Okay? All right.
Hello, ma'am. Do you have a Nadia in your class?
Yes. Nadia. Okay. On one figure, draw the following. Number 1, what is this saying right here?
J.
Ray HJ, a ray that starts at H and goes in the direction of J, and ray HS are opposite rays. Opposite rays is the new word for us. You will need it for your assignment. Guess what opposite rays do?
Go in the opposite direction.
They go in the opposite direction. So if one goes right, the other goes left. If one goes north, the other goes south, right? They go in the opposite directions. So if I want to draw ray HJ, I'm going to start at point H. There you go. And then it's going to go in the direction. And you can make it go any direction. I'm just going left because I know where this picture is going. And it goes in the direction of J, so somewhere along here, it doesn't matter, you can put it close to the arrow, you can put it close to the H, wherever is point J. So that's ray HJ. Okay. Then ray HS, so also starts at H, right? Also starts here. And it's going to go in the opposite direction. And its direction point is labeled with an S. So we drew opposite rays. It says, and point M is between H and J. I can't draw a new H and a new J. I already have them in my picture, so I have to use the H and the J that are there. When it says between, do you think that's the same as saying it's a midpoint?
No.
Okay, I have a question for you right now. It'll help answer. Right now, standing at the, close to the, I don't know what you call this wall, the front of the room if you're thinking about the doorway. Am I between the front of the room and the back of the room?
No.
I am. Am I in the middle of the room? So does between have to be at a midpoint? No. So that's super important to remember, is between does not imply midpoint. It could be a midpoint, but it doesn't have to be. Okay, so when I add a point somewhere here between H and J, I can add it real close to J, I could add it real close to H, or I could add it right in the middle. It doesn't tell me. I can put it wherever I want as long as it's between. If they don't tell me it's a midpoint, oftentimes if I'm drawing my own picture, I try to not make it look like a midpoint, just because otherwise I might start thinking it really is one. Okay? M. Oh look, JMHS. Go Braves. Alright, the last one. I'm going to switch to a pencil for this one. I am not an artist. Don't judge me. Plane J and M contain HS. That means those two planes must be intersecting at that line, because that's the only way that line can be in both. So I get to draw two planes that are intersecting. Okay? When I do that, I like to draw like the wall, the front wall, and the floor is what I think about drawing. Okay? So here's what I do. I start with a rectangle because I'm not fancy enough to draw it tilted. I start with a rectangle. That's my first plane. Plane 1 done. J. Woo. Okay? For my second plane, my floor, it's got to intersect this one. So the first thing I do is I make 2 points across from each other, and that's going to be my intersection. Through those 2 points, I draw like diagonal segments that match each other, that are parallel to each other. So I draw one here, and then I draw a matching one over here. So far, so good? Yeah. Then all I do is connect the fronts together and the backs together, right? So connect the fronts together and the backs together. Now, if you want to get fancy, okay, if two planes intersect, like that wall intersecting this floor, I can't see it anymore, right, underneath the floor. So the part of the wall that I can't see anymore, if you're using a pencil, you can erase it and make it dashed. And then the floor, when it goes on the other side of that wall, I can't see it anymore. So on the other side of the wall, I can't see this floor anymore. So I'm going to make it dashed. So plane J, I'm going to make that my standing up plane, is here. See why I used a pencil? I could do the little erasing and make it fancy. Okay. And then this part right here, oh, I already did dotted line there. And that's plane J. I can put the J in any of the four corners, whichever one I think it fits best in. I'm just going to put it up here. And then the other one is my plane M. So that's this flat one. I never took an art class, guys. Isn't that sad? I know. All right, and that's going to be plane M. So in one of my four corners, I'm going to put an M. I'm just going to put it here. And then the line that is the intersection connects those 2 points I had put. But remember, it's a line, so I'm going to show that it's a line by extending it. And then for points H and S, because, right, the line contains H and S, I can either do like this, and I can make 2 little new points on here and call one H and one S, or I can just use the points that I already drew and make one of those H and one of those S. That looks like a 5. That's an S. Okay? Isn't that pretty? You all just drew 2 intersecting planes. All right.